Today we are going to continue to look at some properties of exponents. So we have 3 more that we are going to add to the list today. Our first one being what we do if we have a negative exponent. So what do negative exponents tell us to do? A negative exponent is telling us that the location of whatever base is receiving the exponent is on the wrong side of the fraction. So it's going to tell us that we need to move the exponent and whatever its base is to the other side of the fraction. Now, when we look at something like x to the negative 5th, we don't see a fraction involved, but we should remember that when there's no fraction, it's really sitting over 1, which means that that x to the negative 5th is currently in the numerator or in the top of the fraction. So to get rid of that negative exponent, we want to move it to the denominator. We want to move it to the bottom. And we need to move everything that has that negative exponent. So you're taking the base, which in this case is x, and its exponent of negative 5 with it. So all of that is moving to the denominator. And then once it gets moved to the denominator, that negative sign comes off. Now, we can't have a fraction with nothing left in the numerator, so our space filler when there's nothing there is really just a 1. And so our answer would be 1 over x to the 5th. Now, the important piece to understand here is that when we are dealing with negative exponents, we'll never write a final answer with a negative exponent in it. So very similar to, we never want to leave a fraction as 2/4. We want to simplify that into 1/2. It's the same thing with a negative exponent. So if we see a negative exponent in a problem, we always want to make sure that we are rewriting it to get rid of that negative exponent. So if we look at our second example here, 4w to the negative 2. Again, we see that negative exponent, but it's really important that we're only identifying what is actually receiving the negative exponent. What is the actual base with it? So w is our base and negative 2 is the exponent. That 4 isn't moving. So we're taking that negative w to the negative 2 and we're moving it to the denominator, right? There's really nothing in the bottom, so that's really a 1. But that 4 isn't moving. So the w, negative 2 is coming to the bottom, and when we move it to the bottom, that negative sign comes off. That 4 is still sitting in the numerator. It's still sitting in the top of the fraction because it did not have a negative exponent. So number 3, again, we see a negative exponent in this one. We have 8 over 3b to the negative 1. And this time our negative exponent happens to be on the bottom of the fraction. Okay, which is okay. It's really just telling us it is on the wrong side of the fraction. So since we see that negative exponent happening on the bottom of the fraction, we want to move that up to the top. Again, we are going to move the base with that exponent, but nothing else. So the 8 and 3 are staying put, and that b is coming up to the top. Now, we would make that a positive 1, but we don't have to write down that 1 there. So we could just put 8b all over 3. Either would be fine. Okay, and then example 4 here. Again, now we actually have 2 negative exponents happening. But as we'll notice, they don't have the same base. They're different letters, which means we can't put them together. We can't simplify them in any way, shape, because they're base. We just need to simplify based on the negative exponent. So the a to the negative 5th is sitting in the top of the fraction, which means we need to move it to the bottom. So if I move that down to the bottom of the fraction, that's going to give me an a to the 5th on the denominator. But we'll also recognize that there's a c to the negative 6, which is also a negative exponent. It's sitting in the denominator, so it needs to come up to the top. Okay, and for our final answer to be rid of all of the exponents, we'll have c to, or all of the negative exponents, I should say, we'll have c to the 6th over a to the 5th. So when we have a negative exponent, our rule is telling us that we are going to move the exponent with its base to the other side of the fraction. The next property that we are going to look at is dividing with exponents. So if we are dividing with exponents, right, division we typically see as a fraction. So if we have something like x to the 7th over x to the 5th, we know that x to the 7th is really telling us x times x times x times x, right? We would have that 7 times. Oops, I'm going to squeeze one more in there. And we know that x to the 5th is really x 5 times. Okay, one of the things that we should already be okay with is that a number over itself is equivalent to 1. So 4 over 4 is 1. 10 over 10 is 1. 100 over 100 is 1. So x over x is just 1, which means every time we end up with an x over itself, we really don't need that. So here's another x over itself, another one, another one, another one. And the only thing that we're left with is those two x's in the numerator, or we're left with x times x, which is x squared. Now, we don't always want to have to write down all of the x's or y's or whatever variable they are and then cancel them out. So what does it look like is happening with that 7 and 5? Well, we are subtracting them. And that is our exact rule. When we are dividing with the exponents are going to be subtracted. Now, any coefficients in front are still going to behave like they normally do. So those are going to be divided or simplified. Okay, but the exponents we are going to be subtracting. So if we look at example 2, if we subtract 2 minus 9, that gives us a negative 7. Now notice, we are taking the top minus the bottom. The numerator exponent minus the denominator, and that gives us a negative 7. We just said in our previous problems that we don't want answers with negative exponents, and for it to be in simplest form, we need to get rid of the negative exponent. Well, a negative exponent tells us that we're moving it to the other side of the fraction. So instead of writing this answer as c to the negative 7th, we are going to write this as 1 over c to the 7th. There are a couple ways that you can think about this. You can decide that you want to do this as 2 separate steps, and you can take 2 minus 9, which gives you negative 7, and then rearrange a negative exponent to the denominator. Or you can just recognize that if you subtract 2 minus 9 and you get a negative number, you need to be writing that on the denominator. There's a third option that you could consider, and that is deciding which of the exponents is larger. And since 9 is the larger exponent, that means our final value is going to have the exponent in the same location as the exponent of 9. Look at example 3 here. Now we have multiple things happening. Sorry, I hit my camera. So when we look at this, we're first going to realize that there's different pieces we can focus on. So we have coefficients. These are going together. And then we have variables with separate bases. So we have a's that we can focus on. And we also have b's that we will need to focus on. Our rule tells us that our coefficients, we are going to divide or simplify just like normal. So this yellow, this 12 over 18, those are our coefficients. We need to divide or simplify them just like normal. 12 divided by 18 does not divide evenly. So we can just find a number that will divide evenly into both of them. 6 will go into both, so 6 goes into 12 twice, and 6 goes into 18 3 times. So that will simplify to 2/3. Then we can look at our a's, so that's what we're going to focus on next. So if I subtract my exponents, 5 minus 3 gives me positive 2. Okay, that's a positive exponent, that's a positive number, so we know that we want to write that in the numerator or in the top of the fraction. Again, another way that you could consider that is 5 is the larger exponent, so we know we want our final answer to be in the location of the larger exponent. Then we will look at our third piece, our b's. This top b doesn't have an exponent, which we don't see, so it's really a 1. So if we take 1 minus 7, 1 minus 7 gives us a negative 6. We could decide to write b to the negative 6 on top, but that would just give us more work to do with rearranging. right? So we know that a negative exponent needs to get moved to the denominator. Again, you could also recognize that 7 is the larger exponent, and so our final answer with that b needs to be in the denominator. Finally, when we look at example 4, okay, same thing, we have two different pieces. So if we look at our coefficient first, I'm going to look at that 5 over 20. Be careful, it's really easy to mistake this to be positive 4, but this isn't 20 over 5, but 5 over 20. They are both divisible by 5, so 5 divided by 5 is 1, and 20 divided by 5 is 4. That 1 in the numerator is optional. We don't have to write that 1 there if we don't want to, because we will have other pieces happening. We want to be really careful when we're dealing with subtraction and this negative. So we know we want to subtract negative 2 minus 2. Negative 2 minus 2 gives us a negative 4. That is negative, so we are going to move that to the denominator. So our final answer will be 1 over 4y to the 4th. So actually, in this case, that 1 is going to be required, right? If we didn't write it down to start with, we would need a space filler, and we would end up filling a 1 in there anyways. Our last property today is what my students would consider the easiest. There are a few small pieces we need to touch base on, but it is a zero exponent. What do we do with a zero exponent? And it tells us that whatever the base is and the exponent, it all just becomes 1. So if we have a number or a variable or whatever, and it is to the power of 0, it is going to equal 1. Okay, so x to the 0 power is 1. It just equals 1. It has an exponent of 0, so all of that becomes 1. Doesn't matter if it's positive or negative. So negative 23 all to the 0 power is 1, right? If it has an exponent of 0, whatever the base is, negative 23 in this case, all becomes 1. So maybe we get something more complex. 22a to the 15th all over 7w to the 11th, but that is all to the 0 power. So everything that is to the power 0 power becomes 1. Now, this is really great, right? Super simple. My students love this idea. Perfect. If we see an exponent of 0, that means the answer is 1. And then we get to this last problem, and it's very tempting to say, well, then that must be 1. But this does not equal 1, because again, the only thing that becomes 1 is the exponent of 0 and its base. The coefficient of 8 is not included in that. That 8 is not receiving the exponent of 0. So the y to the 0 power is becoming 1, but that coefficient of 8 is still there. So we'd be left with 8 times 1, which will give us an answer of 8.